Starship's seventh test flight, a milestone in SpaceX's journey. On January 16, 2025, SpaceX conducted the seventh test flight of its ambitious Starship rocket system, marking a significant milestone in the ongoing development of the world's most powerful rocket. Launched from SpaceX's Starbase facility in Boca Chica, Texas, this flight aimed to further refine the capabilities of the Starship system, an essential component of SpaceX's plans for lunar and Mars missions. Event timeline. Launch time. The mission commenced at 5:37 p.m. Eastern Standard Time, 22:37 Greenwich Mean Time, with the Super Heavy booster and Starship vehicle lifting off successfully. 7 minutes post-launch, the Super Heavy booster successfully executed a catch maneuver, being retrieved by the launch tower's mechanical arms known as chopsticks. 8.5 minutes post-launch, communication with the upper stage, referred to as ship, was lost after the vehicle encountered a critical failure during its ascent. Key outcomes. 1. Successful booster recovery. A highlight of the flight was the successful recovery of the Super Heavy booster. This achievement underlines SpaceX's commitment to reusability and efficiency, allowing for rapid turnaround times between launches. 2. Anomaly in upper stage. Despite the successful recovery of the booster, the upper stage of Starship experienced a catastrophic failure, leading to a rapid unscheduled disassembly. The root cause of this failure was identified as a fuel and oxygen leak that resulted in pressure buildup, causing the engines to fail mid-flight. 3. Flight data collection. Elon Musk stated that the SpaceX team is actively analyzing the flight data to determine the specific causes of the anomaly and to implement design improvements for future missions. Preliminary assessments indicated that the vehicle achieved an impressive altitude of 90 miles 146 kilometers and a speed of 13,245 miles per hour 317 kilometers per hour before losing contact. Commonalities and differences in reporting. Various news sources reported on the test flight, emphasizing both the successful booster recovery and the failure of the upper stage. However, there were differences in the level of detail provided regarding the failure's technical aspects. For instance, CNN focused primarily on the overall mission results, while outlets like Times of India and Space.com offered more in-depth analyses of the failure's causes and implications for future missions, particularly concerning NASA's lunar ambitions. Future implications. While the seventh flight did not go entirely as planned, the lessons learned from this test will inform future iterations of the Starship design. SpaceX has expressed confidence that the challenges faced during this flight will be addressed, paving the way for more ambitious missions in the future. The company anticipates that 2025 will be a transformative year for Starship, with goals set for achieving full reusability and executing increasingly complex missions, including crewed flights to the moon as part of NASA's Artemis program. The development of Starship is critical not just for SpaceX's objectives but also for the broader vision of human space exploration. The ongoing tests and improvements to the Starship system could enable humanity to establish a sustainable presence on the moon and eventually embark on missions to Mars, making this flight a pivotal moment in the quest for interplanetary travel. Conclusion. Starship's seventh test flight epitomizes the iterative nature of aerospace engineering, where successes and failures are closely linked. The successful recovery of the Super Heavy booster demonstrates SpaceX's advancements in reusability, while the upper stage's failure highlights the ongoing challenges in developing a reliable launch system. As SpaceX continues to refine its technology, the insights gained from this flight will undoubtedly contribute to the future of space exploration, establishing a foundation for humanity's journey beyond Earth. The seventh test flight of SpaceX's Starship on January 16, 2025 is a significant event in the landscape of space exploration, characterized by both notable achievements and setbacks. Here are some counterintuitive insights drawn from the details surrounding this test flight. 1. Partial success as a positive outcome. Despite the dramatic failure of the upper stage of the Starship, with Elon Musk referring to it as a rapid unscheduled disassembly, the successful recovery of the Super Heavy booster suggests a nuanced understanding of success in aerospace endeavors. The ability to catch the booster with mechanical arms indicates an important technological milestone, showcasing SpaceX's commitment to reusability, a critical factor in reducing the cost of space travel. This juxtaposition of failure at one stage and success at another presents a complex narrative where setbacks are integral to the development process rather than outright failures. 2. Learning from failure. The accident's aftermath highlights an industry perspective that values failure as a learning mechanism. The SpaceX team emphasized that the data collected from this test will inform future designs, which may seem counterintuitive in a field where success is often prioritized. The acknowledgement that failures provide critical insights into engineering challenges can shift the focus from merely achieving success to fostering continuous improvement. 3. Impact on NASA missions. One might assume that failures in test flights would jeopardize partnerships and future missions, particularly with NASA's lunar ambitions tied to Starship. However, the incident may reinforce the collaborative learning approach necessary for complex missions. NASA's commitment to using Starship for future missions indicates a trust in SpaceX's capacity to iterate and improve upon their designs, illustrating that robust partnerships can endure setbacks when there is a shared goal of technological advancement. 4. Technological advancements amidst failures. The details of the flight reveal that the Starship design incorporated significant upgrades intended to enhance performance. These include modifications to the propulsion system and structural changes aimed at better handling the rigors of spaceflight. This fact challenges the narrative that failures indicate a lack of progress, rather they can coexist with advancements in technology and design. SpaceX's approach to iterative design means that even in the face of failure, progress continues. 5. Expectations versus reality of space exploration. The public and media often frame space exploration as a series of triumphs leading to successful missions, neglecting the inherent risks and failures that accompany technological innovation. The juxtaposition of the Super Heavy's success against the Starship's failure challenges the conventional narrative of linear progression in space exploration. Instead, it illustrates that the path to success is often fraught with obstacles requiring resilience and a willingness to adapt based on real-time data and experiences. 6. Public perception and space industry resilience. The mixed results of this test flight may alter public expectations regarding space missions. While failures can lead to disappointment, they can also foster a more realistic understanding of the complexities involved in space exploration. This recognition may enhance public support for continued funding and enthusiasm for future missions. As stakeholders understand that setbacks are part of the journey toward significant breakthroughs. In summary, the 7th test flight of SpaceX's Starship serves as a powerful reminder that progress in aerospace technology is rarely straightforward. It emphasizes that both successes and failures are vital components of innovation, pushing the boundaries of what is possible in space exploration while shaping the future of human endeavors beyond Earth. The 7th test flight of SpaceX's Starship on January 16, 2025 is a significant event that highlights both the advancements and challenges in aerospace technology and SpaceX's ambitions for future space exploration. While many might focus on the failure of the upper stage of Starship, several important aspects of this event are often overlooked, which carry significant implications for the future of space travel and technology development. 1. Super Heavy booster recovery. The successful recovery of the Super Heavy booster is a critical achievement that is sometimes overshadowed by the failure of the upper stage. This aspect is significant because it demonstrates SpaceX's ability to refine and improve its rocket recovery technology, which is essential for reducing costs and increasing the frequency of launches. The use of the launch tower's mechanical arms, referred to as chopsticks, marks a successful operational milestone for SpaceX's reusability strategy. This not only saves on the cost of production of new boosters but also reflects a broader trend in aerospace engineering where reusability can lead to sustainability in space missions. 2. Technical enhancements to Starship. The modifications made to the Starship's design for this flight are noteworthy. The vehicle's forward flaps were redesigned to reduce exposure to re-entry heating, and the propulsion system received significant upgrades, including a 25% increase in propellant volume. These enhancements are pivotal for the future missions of Starship as they aim to increase the vehicle's performance and mission capabilities. Understanding that these technical changes can lead to improved reliability and safety is crucial as they lay the groundwork for future crewed missions to the Moon and Mars. 3. Impact on future missions. The mission was designed to practice the deployment of satellites, which is particularly relevant as SpaceX plans to expand its Starlink constellation. The loss of the upper stage, while unfortunate, serves as a learning experience that can inform future satellite deployment strategies. The ability to deploy satellites efficiently is directly tied to the success of future communications and internet services in space, which are increasingly becoming integral to both commercial and governmental operations. 4. Data analysis for continuous improvement. Elon Musk's emphasis on data analysis following the flight anomaly highlights an important cultural aspect of SpaceX's approach: the commitment to iterative improvement. Each test flight, regardless of its outcome, provides invaluable data that can inform design and engineering decisions. The acknowledgement of failure as a learning opportunity is a philosophy that can accelerate technological advancements, paving the way for more robust designs in subsequent flights. 5. Significance for NASA's lunar missions. While the direct connection to NASA's Artemis missions may not be the primary focus of coverage, the implications are profound. NASA has contracted SpaceX for lunar missions, and the reliability of Starship is crucial for the success of these missions. The data and insights gained from this flight will directly influence NASA's plans for crewed lunar landings, making the stakes of these test flights much higher than they might appear at first glance. 6. Public perception and media coverage. The media often sensationalizes failures, which can overshadow the achievements and learning opportunities presented by such events. Understanding the importance of the successful booster recovery, the technical enhancements made, and the long-term vision for space exploration is essential for fostering a balanced public perception of SpaceX's efforts. The narrative surrounding space exploration should include both the triumphs and the setbacks, as both are integral to the journey toward human settlement beyond Earth. Conclusion. The seventh test flight of Starship, while marked by the loss of the upper stage, is a complex event filled with significant implications for the future of space exploration. The successful recovery of the Super Heavy booster, the technical advancements made to the Starship, the impact on future satellite operations, the commitment to learning from failures, and the connection to NASA's lunar ambitions all underscore the importance of this event. As SpaceX continues to iterate and improve upon its designs, each flight will contribute to a deeper understanding of rocket science, paving the way for more ambitious missions to the Moon, Mars, and beyond. The interplay of successes and setbacks in this process is vital for the evolution of space travel technology, and recognizing these subtleties can enrich our understanding of the future of human space exploration. 1. Successful recovery of the Super Heavy booster. The seventh test flight of SpaceX's Starship marked a significant achievement with the successful recovery of the Super Heavy booster. The booster was caught by the launch tower's mechanical chopsticks shortly after liftoff, demonstrating SpaceX's capability to reuse rocket components. This advancement in recovery technology is crucial for reducing launch costs and increasing the frequency of launches. The ability to recover and reuse the Super Heavy booster is a pivotal step towards making space travel more sustainable and economically viable. 2. Upper stage failure and implications for future missions. Despite the successful recovery of the booster, the upper stage of the Starship experienced a catastrophic failure, leading to its destruction shortly after launch. Elon Musk indicated that the cause was related to a fuel and oxygen leak, which resulted in a pressure buildup. Understanding the reasons behind this failure is critical for SpaceX, particularly as the Starship system is directly tied to upcoming NASA lunar missions. The lessons learned from this failure will inform design improvements and operational protocols, ensuring that future flights have a higher chance of success. 3. Technical innovations and upgrades. The seventh test flight featured several technical innovations in the Starship design, including modifications to the propulsion system and structural enhancements aimed at improving performance and reliability. These upgrades, such as increased propellant volume and improved avionics, reflect SpaceX's commitment to iterative design and continuous improvement. Such advancements are essential for the ambitious goals of the Starship program, which includes missions to the Moon and Mars, as they enhance the vehicle's capability to support deep space exploration. For impact on future space exploration and NASA collaborations, the outcomes of this test flight have broader implications for future space exploration, particularly in relation to NASA's Artemis program, which aims to return humans to the Moon. SpaceX has secured contracts to provide Starship as a lunar lander, and the success of these tests is integral to the timeline and feasibility of those missions. The mixed results of this flight, especially the successful recovery of the booster despite the loss of the upper stage, underscore the iterative nature of space exploration, where failures can lead to valuable insights and advancements that ultimately push the boundaries of human capability in space. 1. Apollo 1 1967. The Apollo 1 mission, originally designated AS-204, was intended to be the first crewed flight of NASA's Apollo program. However, on January 27, 1967, a cabin fire during a pre-launch test on the launch pad resulted in the tragic deaths of all three astronauts, Gus Grissom, Ed White, and Roger B. Chaffee. This incident highlighted significant safety issues within NASA's spacecraft design and prompted fundamental changes in engineering practices, safety protocols, and management oversight within the program. The aftermath led to improvements in spacecraft design, ultimately contributing to the success of subsequent Apollo missions, including the historic Apollo 11 moon landing. 2. Challenger disaster 1986. On January 28, 1986, the Space Shuttle Challenger broke apart 73 seconds into its flight, leading to the deaths of all 7 crew members aboard, including schoolteacher Krista McAuliffe. The disaster was attributed to the failure of an O-ring seal in its right solid rocket booster, which allowed hot gas to escape and damage the external tank. This incident led to a re-evaluation of NASA's safety culture, redesign of the shuttle's boosters, and the establishment of more rigorous oversight and management practices. The Challenger disaster profoundly affected public perception of space travel and the risks involved, resulting in a suspension of the shuttle program for nearly 3 years. 3. Mars Climate Orbiter 1999. NASA's Mars Climate Orbiter was a robotic space probe launched in 1998 to study the Martian climate. However, on September 23, 1999, the spacecraft was lost due to a failure to convert units between metric and imperial systems, resulting in a trajectory that brought it too close to Mars, causing it to disintegrate in the Martian atmosphere. The mishap underscored the importance of rigorous engineering standards and cross-checking systems, which led to a comprehensive review of NASA's project management practices. Following the incident, NASA implemented stricter guidelines for future missions to ensure better communication and integration across different teams and disciplines. The seventh test flight of SpaceX's Starship on January 16, 2025 represents a significant milestone in the company's quest to revolutionize space travel. Despite facing challenges, including the loss of the upper stage, this flight has important implications for the future of space exploration and technology. Key outcomes. 1. Super Heavy booster recovery. The successful recovery of the Super Heavy booster using the launch tower's mechanical arms is a notable achievement. This marks a crucial step toward achieving the goal of full reusability for the entire Starship system, which is essential for reducing costs and increasing the frequency of space missions. 2. Upper stage failure. While the booster performed well, the upper stage suffered a catastrophic failure approximately 8.5 minutes into the flight due to engine issues stemming from fuel and oxygen leaks. This rapid disassembly highlights the technical challenges SpaceX still faces, but it also serves as a learning opportunity for engineers to refine the design and improve reliability. 3. data analysis and future improvements. Elon Musk and the SpaceX team are focusing on analyzing flight data to identify the root cause of the failure. The insights gained from this event will guide enhancements in the Starship's design and operation, ensuring safer and more successful future missions. Future outlook. The challenges and successes of the seventh flight have strong implications for future missions. 1. Increased testing frequency. SpaceX plans to conduct more test flights in 2025, aiming to refine the Starship system further. With the lessons learned from each flight, the company is positioned to make rapid advancements, potentially leading to several successful missions within the year. 2. Support for NASA missions. The development of Starship is closely tied to NASA's Artemis program, which aims to return humans to the moon by the late 2020s. SpaceX has secured contracts to provide transport for lunar missions, and the ongoing tests are crucial for meeting NASA's ambitious timelines. 3. Commercial opportunities. The Starship system is also expected to facilitate commercial endeavors such as deploying satellites and supporting space tourism. The test flight's intent to deploy dummy satellites underscores SpaceX's ambitions to bolster its Starlink broadband network and expand its services in low Earth orbit. For interplanetary exploration, as Starship aims to become the backbone of human exploration beyond Earth, successful iterations will pave the way for missions to Mars and potentially other celestial bodies. SpaceX envisions facilitating human settlement on Mars, which hinges on the reliability and scalability of the Starship system. 5. Technological innovation. The ongoing development of Starship is likely to inspire advancements in aerospace technology more broadly. As SpaceX continues to innovate with reusable rocket systems, other companies and space agencies may adopt similar strategies, fostering a new era of cost-effective and sustainable space travel. Conclusion. Despite the setback of the upper stage explosion during the seventh test flight, SpaceX's Starship program remains on a trajectory toward a transformative impact on space exploration. The successful recovery of the Super Heavy booster and the commitment to learning from failures are essential elements of SpaceX's approach. With increased testing planned for 2025, the company is poised to overcome current hurdles and make significant strides in paving the way for a new era of space travel characterized by reusability, lower costs, and ambitious missions to the Moon, Mars, and beyond.